Hello everyone, welcome back to Algebra 1-2. Our topic today is dividing polynomials, and in this lesson we are going to be looking back at long division in particular and understand its mechanics to revise that long division we did a long time ago and use its mechanics to divide one polynomial by another. It's actually very useful to learn to divide a polynomial by another using long division. Sometimes we may simply need to simplify an expression in algebra. Other times we may need to factorize a polynomial that has a higher degree, and so we need to divide out something first. So first we're going to be looking at how to use long division to divide two numbers, and once we understand how that works, we're going to apply that same principle to dividing algebraic expressions or polynomials. Now let's look at how to divide 158 by 3. We call this our divisor, 3. We call this our dividend, and the answer that we get will be our quotient and remainder, if there is a remainder. So let's write it up in the algorithm. So we have 158, and we're going to divide it by 3. Now we start by saying, looking at the first number here, how many 3's can we get out of 1? Can't. Then we go to 15. How many 3's can we get out of 15? That would be 5. 3 5's are 15. Do the multiplication there and write down that 15. I should take out this line so it doesn't cause any confusion. So here we have 15, and we're going to do a subtraction now. So 15 take away 15, that leaves a 0. And so we're going to drop down this 8 and continue the division. Now 3 into 8, that is 2 times. We can get 2 3's out of 8. 2 3's are 6. And 6 from 8 leaves 2. And so in writing up this, this answer, we can say that 158 divided by 3 is the same thing as 52 times 3 plus 2 over 3. This number here is our remainder. Very important. This is our quotient. And this here, of course, is our divisor. So 158 divided by 3 can be written as 52 times 3 plus 2 over 3, and that would give us 158 over 3. Now let's try it again. Say here we have 15,768, and we're going to divide it by 12. So let's set up our algorithm. 1, 5, 7, 6, 8. And we are going to divide by 12. So we can take a 12 out of 15, and 12 ones 12. 12 from 15, we do a subtraction there. That would leave us this with 3. And so from here now we can drop down this 7. And let's say, okay, how many 12's can we take out of 37? That would be 3. 3 12's are 36. And 36, do the subtraction. It's always subtraction. 36 from 37 leaves 1. Now we need to drop down the 6. So we have 16. And the 12 from 16, of course, that's 1. We can take 1 12 out of 16. That leaves us with 4 when we do the subtraction. 12 ones are 12. And the last number to come down would be the 8. We drop down our 8. And the 12 into 48 goes 4 times. And we can say, okay, now 4 times 12 is 48. We do our subtraction and we get zeros at the end. In this case, there is a 0 remainder, or there is no remainder. And we can therefore say 15,000 rather, 768 divided by 12. Let's just write that down here. 15,768 divided by 12 is equal to 12 times 1,314. So in some cases, we get a remainder. In other cases, we get a zero remainder or no remainder. So this is how we apply this is how we use long division to divide numbers. Let's now see if we can use long division to divide polynomials. So here we have a question, and this one should come out pretty simple. Here we have x squared plus 5x plus 6, and we're dividing by x plus 2. In most cases, we're going to be using linear factors of this type. It doesn't have to be, but for the purpose of doing this division, it makes it a lot simpler. We could have another type of linear factor or other types of factors. But right now, we want to keep it simple. So let's go x squared plus 5x plus 6, and we want to divide it by x plus 2. So let us set up our algorithm. And here we have x squared plus 5x plus 6, and we want to divide by x plus 2. There are other ways to do this. There's another method called synthetic division, which we're going to look at in a different lesson. But in this lesson, we're focused on using long division. Now, here, first thing we're going to do is to use the x. So when we were dividing the numbers, there was only one thing there. It was just a number there. Here we have an expression, x plus 2, and so we're going to divide it in parts. So we're going to start with the x first, and we're going to say x into x squared. Now, x squared divided by x is just x. And so now we're going to take this x and multiply here. So x times x gives us an x squared, and 2 times x gives us 2x. So first we say x into x squared, that gives us x, and then we multiply x times x is x squared, and 2 times x is 2x. We draw our line, and we're going to subtract. So x squared take away x squared, that gives us a 0. And here 5x take away 2x gives us a 3x. And then now we're going to drop down the next number, or next term, that is 6. And then we're going to divide using the same process again. So x into 3x here would give us 3. And then we go about saying x times 3, that's 3x. And 2 times 3, that's 6. And so we write that. We set up our subtraction. 3x take away 3x is 0, and 6 take away 6 is 0. So it ends here. And what this is telling us is that x squared plus 5x plus 6 divided by x plus 2 is equal to x plus 3. Or writing that another way, x squared, which is the numerator here, plus 5x plus 6 is the same thing as x plus 2 times x plus 3. So we can use long division as a way to get out a part of our factor in factorization. And of course, there are easier ways to factorize this, but when the degree here gets a bit higher, it's not so easy to factorize. And so sometimes we want to find a way to get out a factor first, so we can reduce our expression to quadratic form, and then we can apply that other form of factorization. So here, we have x squared plus 5x plus 6 divided by x plus 2 gives us x plus 3. Now let's try another one, a little bit more degree. So we have x to the third plus 4x squared minus 8. Notice in our numerator here that we do not have the term containing x. The powers are 3, 2, it should be 1. Then we don't have that x term. When we don't have the x, if we have a term that is missing, let's put it that way, we should try to write them in, because it makes things a bit easier to deal with. So now we're going to divide by x plus 1, and we're dividing x to the third by plus 4x squared. And notice that there is no x term, so I'm going to write here 0x minus 8. You do not have to write it, but in the beginning here, just because I'm trying to explain it, it makes sense to write it. So here, we're going to divide by x plus 1, and first we're going to say x into x cubed. That would give us an x squared. And then x times x squared now gives us back x cubed, and 1 times x squared gives us x squared. And remember, we're going to draw a line. We're going to do a subtraction. X cubed take away x cubed, that's gone. And 4x squared take away this x squared gives us a 3x squared. Now we want to drop down the next term, and the next term would be this. So we do the same process again. x into 3x squared gives us 3x. And multiplying x times 3x is 3x squared. And 1 times 3x gives us a 3x. Do that subtraction. 3x squared take away 3x squared. That's 0. And 0x take away 3x gives us a minus 3x. Now, once we have that minus 3x, we drop on the next term, which is minus 8. And we're going to do the division again. X into minus 3x gives us a minus 3. And x times minus 3 gives us minus 3x. And 1 times minus 3 there gives us a minus 3. So here we have it. Negative 3, we're subtracting negative 3 minus another negative 3. That is the same thing as saying negative 3 plus 3. That's a 0. And negative 8 minus negative 3 is the same thing as saying negative 8 plus 3, which gives us a negative 5. So here we have a remainder. And so x to the third plus 4x squared minus 8 divided by x plus 1 is equal to this divisor here, x plus 1 times x squared plus 3x minus 3 plus our remainder. And our remainder is, I should write this 3 a little better, just a moment here, minus 3 plus our remainder, which is negative 5 over what we're dividing by, x plus 1. Let's just move it a little bit closer here. So when we divide x to the third plus 4x squared minus 8 by x plus 1, what we end up with is the result x plus 1 times this plus our remainder of negative 5 over x plus 1. So sometimes in dividing, you end up with a remainder, and sometimes a question may say find the quotient and the remainder. So the quotient would be this. Let me get my pen. So this is the quotient. And our remainder, of course, is negative 5. We're going to be doing some interesting work later on. And notice negative 5 here has a very special meaning. If you should look at this function expression here, x plus 1, and you should find f of minus 1, then when you plug negative 1 into this expression, you're actually going to get the remainder, which is minus 5, which becomes very, very useful later on. So this is our remainder, and this is our quotient. All right, let's try another one. Here we have a much bigger function, much bigger polynomial in our numerator, and we're going to divide it by x minus 3. So sometimes we want to factorize something like this, and we cannot apply the obvious knowledge that we know to factorize them, such as we factorize quadratics. So we have to find a way to reduce it. And one way to reduce it, as we said, is to apply this long division idea to it. So we're going to write it out. We're dividing by x minus 3. And let's just write it in there. X to the fourth minus 5x to the third minus 2x squared plus 25x minus 3. So all our terms are there, 4, 3, 2, 1, 0. Very good. And so we can go ahead and divide by x minus 3. Now here we go. X into x to the fourth will go x to the third. And then we multiply. X times x to the third gives us x to the fourth. Of course, we're going to multiply this. Negative 3 times x gives us a negative 3x to the third. Let's just write that properly there. And do our subtraction. So x to the fourth take away x to the fourth, that's gone. And then negative 5x to the third minus 3x to the third. That's a negative 5 plus 3 gives us a negative 2x to the third. And we're going to drop down our next term, which is minus 2x squared. Now let's divide again. X into minus 2x to the third gives us a minus 2x squared. And multiplying here, x times this gives us minus 2x to the third, and negative 3 times negative 2 here gives us a plus 6 x squared. Let's do a division again. So here we have negative 2 minus negative 2, that gives us a 0. And negative 2 minus 6 here gives us a negative 8x squared. Negative 2 minus positive 6. Drop this one down next. That's 25x. And here we divide again. X into negative 8x squared gives us negative 8x. Very good. And x times negative 8x, of course, gives us a negative 8x squared. And negative 3 times a negative 8 here gives us a negative 24. A positive 24 rather, 24x. All right. So we're going to divide again. We're going to subtract rather. So this subtract this gives us a 0. Negative 8 minus negative 8, which is the same thing as negative 8 plus 8. So that's gone. Then 25x minus 24x, that leaves us with just a x. And we're going to drop down our last term, which is minus 3. So here we go. X into x here gives us 1, positive 1. And x times 1, that gives us an x. And negative 3 times 1 gives us a minus 3. Notice that here it divides out cleanly. When we subtract that out, there's no remainder. And so what you find then is that this expression, x to the fourth minus 5x to the third minus 2x squared plus 25x minus 3, all of that divided by x minus 3 gives us simply x minus 3 multiplied by our quotient, which is x to the third minus 2x squared minus 8x plus 1. So what we have found is one factor. That would mean that x minus 3 is a factor of this whole expression here. And then if we wanted to factorize this bigger expression here, then what we would do is to continue looking for factors such as trying x minus 1, x plus 1, etc. on this part until we reduce it to a quadratic where we can, if it can be reduced to a quadratic, and then we continue until we factor it out entirely. So this is, like I said, a very, very important skill to learn when we are trying to factorize expressions that have degrees bigger than 2, such as these 3, 4, x to the fourth, etc., etc. That's our answer there. And we have one more question. Here, we are not using the linear factor as we did here. We're using a quadratic factor. And the process is pretty much the same. What we do is that we write out our divisor. So we're going to be dividing by x squared minus x plus 1. And we want to divide x to the third plus 6x squared minus 6x plus 7. So let's get all of that under there. And the process is pretty much the same as we did before. We take the x squared, we divide it into x cubed. And x squared into x cubed, of course, gives you x. And x times x squared times x here gives us our x cubed. Negative x times x gives us a minus x squared. And 1 times x gives us a plus 1x, or just x. And we write that there, we do our subtraction. X cubed take away x cubed, that's gone. 6x squared minus a negative x squared gives us a 7x. And negative 6x minus x gives us a minus 7x. And now, rather this is a square. Let's write that. And let's drop down our last term, which is 7. So now we're going to divide again. X squared into 7x squared. Of course, that's just going to give us a plus 7. And here we're going to multiply. X squared times 7 gives us 7x squared. Negative x times 7 gives us a negative 7x, and 1 times 7 gives us 7. And as you realize, the two expressions here and here are identical. So once you subtract them, you're going to be ending up with 0, 0, and 0. And what that means is that x cubed plus 6x squared minus 6x plus 7 is going to be equal to x squared minus x plus 1 times x plus 7. So this multiplied by this would give us that dividend in our numerator. So that's our answer there. So sometimes, like I said, when you divide, you get a remainder. Sometimes when you divide, you don't get a remainder because the thing that you're dividing by is actually a factor. This is a very, very important skill that we need to learn. This is how we do it. And now that we have gone through it, it's your turn to go get some practice to make sure that you tie down that skill, that you understand exactly by doing many, many examples and testing yourself by even trying harder ones. If you haven't subscribed to the channel, then please do. We thank you for your support, as always, and thank you for watching.